Welcome Shemstars to computer class. Yesterday we studied types of networks in which we covered LAN, MAN, PAN and WAN, that is local area network, metropolitan area network, personal area network and wide area network. Today we are going to start with network topologies. So let us start with network topologies. The pattern of interconnection of nodes in a network is called topology. The selection of topology for a network cannot be done in isolation as it affects the cost of media and access method used. There are a number of factors to consider in making this choice, the most important of which are set here. First is cost. For a network to be cost effective, one would try to minimize installation cost. This may be achieved by using well understood media and also to lesser extent by minimizing the distance involved. Second is flexibility. Because the arrangement of furniture, internal walls, etc. in office is often subject to change, the topology should allow for easy reconfiguration of network. This involves moving existing nodes and adding new nodes. Third is reliability. Failure in a network can take two forms. Firstly, an individual node can malfunction. This is not nearly as serious as the second type of fault where the network itself fails to operate. The topology chosen for the network can help by allowing the location of the fault to be detected and to provide some mean of isolation to it. Next is point-to-point link. Before we talk about topologies in detail, let us learn about point-to-point link. To understand this, I'll be showing you this picture here. Point-to-point link basically relies upon two functions, transmit and receive. The main characteristics of P2P network is that each station receives exactly from one transmitter and each transmitter transmits to exactly one receiver. The transmit and receive operation can occur over separate wires for better performance, or they can take turns over the same wire using variety of techniques. Point-to-point network can grow in several ways. One method is simply to install a P2P link between each pair of computers in the network. This approach is called a mesh. Many topologies have been developed, but major ones are star topology, the bus topology, ring or circular topology, tree topology, graph or mesh topology. Now let's start with star topology. This topology consists of central node to which all nodes are connected by single path. It is the topology used in most existing information network involving data processing or voice communication. The most common example of this is IMB 370 installation. In this case, multiple 3270 terminals are connected to either a host system or terminal controller. Here I am going to show you a picture of star topology, where all nodes are connected to a single server and even printer is connected to the server. Next is bus or linear topology. Another popular topology for data network is the linear. This consists of a single length of transmission medium, normally coaxial cable, onto which various nodes are attached. The topology is used in traditional data communication network where the host at one end of the bus communicates with several terminals attached along its length. The transmission from any station travels the length of the bus in both directions and can be received by all other stations. The bus has terminators at either ends which absorb the signal, removing it from the bus. Data is transmitted in small blocks known as packets. Each packet has some data bits plus a header containing its destination address. A station wanting to transmit some data sends it in packets along the bus. The destination device, on identifying the address on the packet, copies the data onto its disk. Here I am showing you this picture of bus topology in which a server is connected to a number of nodes and a single bus is running. You can see this linear line here, and each and every node is connected to it, including printer. Now next we are going to discuss is ring topology. The third topology that we will consider is the ring or circular. In this case, each node is connected to two and only two neighboring nodes. Data is accepted from one of the neighboring node and is transmitted and onwards to another. Thus, data travels in one direction only from node to node around the ring. After passing through each node, it returns to the sending node, which removes it. It is important to note that data passed through rather than travels past each node. This means that signal may be amplified before being repeated or on outward channel. Here I am showing you a picture of ring topology in which one-to-one connection is there from one node to another. Next, let's discuss about the tree topology. A variation of bus topology is the tree topology. The shape of the network is that of an inverted tree with the central root branching and sub-branching to the extremities of network. Transmission in this topology takes place in the same way as in the bus topology. In both cases, there is no need to remove packets from the medium because when a signal reaches the end of the medium, it is absorbed by the terminators. Tree topology is best suited for applications which have hierarchical flow of data and controls. Since the tree topology is a modification of a pure network topology, bus topology, it is a hybrid topology. Here in this picture, I am showing you how a root at the top is connected to its child, or we can say nodes or workstations. Next, we are going to discuss about graph topology. In this topology, nodes are connected together in an arbitrary fashion. A link may or may not connect two or more nodes. There may be multiple links also. It is not necessary that all the nodes are connected, but if a path can be established in two nodes via one or more links, it is called a connected graph. Here I am going to show you a graph topology. So here all these nodes are connected to one another. Next is mesh topology. In this topology, each node is connected to more than one node to provide an alternative route in case the host is either down or too busy. It is extension of P2P network. The mesh topology is excellent for long distance networking because it provides extensive backup, rerouting and pass-through capabilities. Communication is possible between any two nodes on the network either directly or by passing through. This function is needed in the event of a line or node failure elsewhere in the network. The mesh topology is commonly used in large interworking environments with star, ring, and buses attached to each node. This is also ideal for distributed networks. Here is the picture of mesh topology. Next is fully connected. In this topology, when in a network, each host is connected to other directly, that is, there is direct link between each host, then the network is said to be fully connected. This characteristics is termed as fully connected. Here is the picture of fully connected in which each and every node is connected to the other node. There are few factors to consider for topology selection. First, cruciality of work. How crucial the continuity of work is a very important factor. For instance, military network must not fail at any cost. Thus, fully connected topology is a preferred for military networks. Next, we are going to discuss about cost. Keeping in mind the budget, you should decide about a topology. Linear bus topology network may be the least expensive way to install a network. Fully connected is the most expensive. Next is length of cable needed. Sometimes length of cable must be saved on the linear bus topology network uses shorter length of cables. Next is future growth. If a network has to grow in future, then the topology must support expansion. With the star topology, expanding a network is easily done by adding another concentrator. And last, which we are going to discuss, is communication media. Sometimes difficult terrain like hilly areas do not allow use of regular cables. For such condition, linear bus topology are not possible. The most common cable in schools is unshielded twisted pair, which is most often used with star topology. So we are going to discuss this much only, and tomorrow we will be discussing network devices. Thank you, Shemstars. That's all for today. You can drop your queries on the Google Classroom. Take care.